Here in this video, we are solving two simple questions that appeared in NEET 2022 in Mechanical Properties of Fluids chapter topic. See, the first question is, a spherical ball is dropped in a long column of a highly viscous liquid. The curve of the show graph which represents the speed of the ball as a function of time is. So we need to understand first of all what he is asking for. So he is saying that there is a ball, it's moving in a heavy liquid. So imagine it's all a heavy spherical liquid. Let us see what are the forces acting on that ball. It's definitely having some mass, so its weight will be always acting in a downward direction. It's a fluid. Fluid always applies a force called upthrust. Upthrust is always in an upward direction. The motion of the ball is downward. It was dropped. It was given that it was dropped. So it's a motion. And it was given that it is a viscous fluid. As it is a viscous fluid, there will be opposition called viscous force acting against the motion. As the motion is downward, the viscous force acting will be upward. So there is another extra force that we need to consider in viscosity called viscous force. According to Stokes' law, that viscous force is 6 pi eta Rv, weight is mg, upthrust is volume of the fluid displaced, density of the fluid into gravity. So what happens as time progresses, we can see as time progresses, we can see very clearly that mg is constant, it's not going to change. Upthrust is also constant. But look at this viscous force, 6 pi eta r is constant, but as the body is coming down, its velocity is increasing because there is a resultant weight which is more than the upthrust acting in a downward direction. As the velocity is increasing, overall this viscous force is also increasing. So the downward force acting is weight and upthrust. Upthrust is upward, right? So the downward force acting is weight, upward force acting is upthrust and viscous force. Initially weight is dominating, so that its velocity will be keep on increasing with respect to time. At a certain stage, as the viscous force increases, the overall upward force also increases, where the upward force acting balances the downward force. So the body acquires a constant velocity, and that constant velocity is called as terminal velocity, right? So as balanced ball or body acquires a constant velocity, called terminal velocity. So what happens? So there is a derivation for that. I am not going to derive it, but I can write it for you. 2 by 9 r square rho minus sigma of eta by something like that, whatever maybe the derivation is. One thing, the most important thing that we need to understand is initially velocity increases and later velocity remains constant. This is the graph that is saying it. Velocity is initially increasing and then it remains constant. So option B, answer B, curve B is the right answer. So B is here in option C. So that's the right answer for the problem. That's how we solve that simple question. Let's have a look at the next question. Next question, this is also a conceptual question. Look at the next question. What it says is, if a soap bubble expands, the pressure inside a soap bubble is. So first of all, what you need to know is, there is a soap bubble, inside there is a fluid. That fluid always applies tries to, because of the surface tension, it always tries to acquire the minimum surface area. So the bubble always tries to be as spherical and as small as it is possible, because it's all pulling inwards. There is an excess pressure generated inside. Excess pressure in a water drop is 2T by R, in a soap bubble that is 4T by R, where this T is nothing but the surface tension of that liquid. R is the radius of that drop. Now he is saying as the bubble expands, so what happens? As the bubble expands, surface tension property of the fluid remains same, but the radius increases. Being radius is in the denominator, that excess pressure, as the radius increases, excess pressure decreases. So the excess pressure decreases, right? So it decreases. Here is the answer, right? So the answer is this, it decreases. That's how we solve that simple question, right? That's second question. Both are the questions in mechanical properties of fluids. Thank you for watching.